Hello my friends. So in this video we're going to start the 8th test. We are going to do the first chord section of the 8th test of Big Book GRE. In case you are new, you will see the previously short videos in the description. Basically what we are doing is we are going through the GRE Big Book, a thick book that was published in the 90s. We are going through that. In this particular series, we are only doing the quant section, but we will also do the verbal section after the quant section, right? The best way to use these videos is to solve along so that you're not just in the watching mode, but you're more actively involved with the material. And the objective should be to identify what kind of errors you are doing and sort of uncover your own testing strategies or lapses, behavior, and things like that. Okay, so let's get right into the questions. So as you can see, this is test 8, section 2, 30 minutes, 30 questions. Let's look at the first question. Question 1, a team won 75% of the 24 games it played. So what would be 75% of 24 games? You could do it multiple ways. 75% can be basically written as 3 by 4 of 24. So that is 18 games, right? Or you could also do 24 into 0.75. That way also you can do. But the numbers are always easy on these kind of questions. So 75% you can easily figure out that it's 18. So we have 18 here, we have 20 here. What do we have to do? We have to find the biggest number. The biggest number is in column B. So answer is B. Okay, question 2, 4 into 10 raised to 5. Okay, and that needs to be compared with 400,000. Okay, so what is 10 raised to 5? 10 raised to 5 is 1 followed by 5 zeros. So that would be 1, 2, 3, 4, 5. Multiply by that by 4. So this is 400,000, right? If we can put a comma here, same here, 400,000. Reason I'm drawing this big line is just for me to count the numbers. Okay, sometimes it becomes a little confusing when we have more number of zeros than we can imagine. So this is 400,000, this is also 400,000, same quantity we have. So answer is going to be answer choice C. Okay. Question 3, R to be compared with 0. That means whether R is positive or negative. All right. What do we have? RT is equal to 0. Okay. So that means one of them or at least one of them. Both can also be 0. So possibilities of R is 0 or T is 0 or R and T both are 0, right? 3 possibilities. But then in the second statement they are saying T is not equal to 0. So this possibility is out, this possibility is out. So that means R has to be 0, right? Only R can be 0. T can be positive number or negative number. So R is 0. So we have 0 here, we have 0 here. Again, answer is going to be C. Okay, let's look at question 4. 8 minus minus 12 minus 5. Okay, so let's do it here. 8 minus minus 12, minus minus becomes plus. So you get 8 plus 12 minus 5. Okay, and what do I have here is I have 5 minus 8 plus 12, right? So this is just there is no minus here, so minus 8 remains minus 8. So let's find out. This is 20 minus 5, right? This is 20 minus 5, and this is 5 minus 8 is minus 3 plus 12, right? So this is 15 and this is 9. Okay, let's verify. So this is 20 minus 5, 15, correct? This is minus 3 plus 12. Let me do it a different way so that if in case I've done a silly mistake. So this is 4 plus 5. Okay, all right. So this is correct. This is 9 and this is 15. Answer is going to be answer choice A. Okay, let's do question number 5 in a different color. Question 5, 7 cars were used to transport the members of a chess team to their match. Okay, 7 cars, 1, 2, 3, 4, 5, 6, 7. All right. And each car contained either 4 team members or 3 team members. Okay, so it could be either 4 or 3. Same thing here, each for each car. Okay, 4 or 3. Total number of members on the chess team. Okay, so let's say what is the minimum and maximum? If each car is carrying only 3 members, each of them, so that would be the minimum, right? No car is carrying more than 3. So the minimum would be 3 into 7 cars is 21. What would be the maximum? Maximum is each car is carrying 4 members. So that would be 4 into 7 cars would be 28. Do we have any information apart from this minimum maximum calculation? We don't really have any information. The only constraint or every only information that we have is that it can either be 4 or 3 only. Okay, so it could be any number in between 21 or 21 to 28. It could be any number, right? Can we compare that with 5? In some cases 21, 22, 23, 24 it will be a different answer. For 25 it will be a different answer. For 26, 27, 28 it's going to be a different answer. So we can't really determine. Answer is answer choice D. Okay, let's move on. Question number 6. Root 41 plus root 59. Okay, do they expect us to know this number? No, right? But we can intelligently guess that this is more than root 36. Correct? So root 36 is 6. That means this is something like 6 point something. Okay, why is it not 7 point something? Because this is still less than 49. So this is between 36 and 49, which is the square of 6 and square of 9. So the square root of this number has to be 6 point something. Same thing here. This is between 49, which is 7 square, and 64, which is 8 square. So this has to be something like 7 point something, right? So together I can say it's going to be something like 13 point something. It could be 14 point something also, but it has to be at least 13 point something, right? And this is 10. So this is 13 point something, this is 10. Answer is going to be answer choice A, right? Okay, let's change the color. Question 7. 2x plus 5y is equal to 24, and x can be anything between 1 and 3. It could including 1 and 3. Okay, that's the only information we have. All right, how do we go about this? Let's put x is equal to 1, right? And then we'll put x is equal to 3 and we'll see what happens. Okay, so let's say x is equal to 1. So what do I get here? I get 2. 2 into 1 is 2 plus 5y is equal to 24. That means 5y is equal to 22. That means y is equal to 22 by 5, which is 44 by 10, which means 4.4. Okay. So when x is 1, y is 4.4, I get x is less than y. Okay, that means B as an answer. But let's say what happens when x is equal to 3. When x is equal to 3, I get this becomes 6. 6 plus 5y is equal to 24. So 5y is equal to 18 and y becomes 3.6. Okay, so in that case also x is less than y. X is less than y. So in extreme cases also x is less than y. Okay, let's take a middle number, let's say 2, just for simplicity. X is equal to 2, so I get 4 here. So 4 plus 5y is equal to 24. So 5y is equal to 20, y is equal to 4. Okay. In that case also I'm getting the same relationship. X is always less than y. That means answer is going to be answer choice B. Okay, let's look at question 8. X plus 1 and x square have to compare, and x is greater than 0. Okay, x is greater than 0. But we have seen in some of the previous tests also that behavior of x square changes based on whether x is greater than 1 or not. Okay, so is that something to be worried about here? Anyway, I mean, we don't really have to think too much. Just pick some number. Let's pick couple of numbers. Okay, and we will see what happens. So again, x is greater than 0. So let me put x is equal to 1. Right. So what do I get here? X plus 1 becomes 2. X square becomes 1. I get this relationship. When I put x is equal to 100. Okay, x plus 1 becomes 101. X square becomes 100 times 100. That is this. I get this relationship. Right. So I'm not able to determine anything. I really don't have to complicate it by taking fractional numbers and everything. It's not really needed. Answer has to be answer choice D. Question 9. ACEF is a square. ACEF is a square. Let's say x square All right, this is 45 degrees. This total thing is 90, so this also has to be 45. Basically, this is sort of a if I extend this line, it's going to touch point C. Okay, it's a diagonal of the square. Okay, the area of the triangular region BCD, that is this BCD, that is this. Okay, that is 1, right? Uh, do we have any other information? We don't have any other information, so we can't really know what is the slope of this angle. As in, is it it is going at 45-degree angle? Is this, let me give the different color, is this angle a 45-degree angle? Okay, in that case, if I draw this line, this part and this part, these two small parts are going to be equal. Okay, but that doesn't have to be the case. They have not told us that. It could be very much like a thing like this. Okay, this is 45 degrees, so that is fine. But this triangle, I'm talking about this BCD, this could be like this. Okay, we don't really know. All we know is that the area is 1. Okay, we also don't know what x is. Okay, how do we compare the area of region ABGF? ABGF. Okay, so they are asking me to compare this with 3.5. Okay, now 3.5 is a small number, right? It is possible, like I said, this triangle to be any triangle in any direction for a very big square. Let's say this is 100. We can, and sort of this is the diagonal line that is there. Okay, we can still come up with one triangle that has area of 1 somewhere here. Okay, in that case, or ABGF, that is this area, okay, is going to be much bigger than 3.5. Correct? Or it is also possible that I have a small area, small square rather, okay, where this area is 1, this area remains 1. Okay, and then this area could be 3.5, or this could be less than 3.5 also. What would that case be? Let's take, if this is 1, let's take a standard case. uh, this will have to be for this area. Let's say, assume that this is 45 degrees. Okay, this angle is 45 degrees. So here, for the area to be 1, we will have to have sides as √2. Correct? In that case, the area is going to be like this. The 2 into √2 is going to be 2. 2 into half is going to be 1. Okay, so √2. And let's say this is also √2. Okay, √2. Right, so this square becomes 2 √2. The side of the square becomes 2 √2, and the area becomes 2 √2 square. That means 4 times 2 is equal to 8. Okay, so this will still be 3.5. I'm looking for a case where this will have to be less than 3.5. Is that possible? Let's say that this is only marginally greater than √2. Okay, √2 point something. I mean, basically, let me just redraw it just for the sake of simplicity. Let's construct a triangle where this is 45 degrees, right? Let's say it's like this. This is √2. This is √2 as we calculated, and this is something very marginally greater than √2. Okay, in that case, what would be this area? That's what I'm trying to calculate. So let's say this is √2 is what, 1.4. So let's say this is the whole thing is 1.5 only. Okay, so this is 0.1, this is 1.4, this is 0.1. So the whole side of the square becomes 1.5. Okay, 1.5 into 1.5 is 2.25. Okay, so 2.25 is the whole square. Then obviously this is going to be much smaller than that. It's going to be less than half, right? uh, that means there is a possibility that we can draw a square where this ABGF area is less than 3.5. Both possibilities are there. If the square is large enough, like we had drawn earlier, 100 units, okay, It could be much bigger than 3.5, but there is also a possibility that it could be less than 3.5. Again, the answer is going to be D. Okay, let's look at question 10. The area of a rectangular region with sides of lengths 25 and 3.1. Okay, rectangle 25 and 3.1. Let's say this is 25, this is 3.1. What is the area? Area is going to 25 into 3.1. Okay, fine. The area of a circular region with radius 5. Okay, so this is circular region, radius is 5, r is equal to 5. What is the area here? Pi r square. R square is going to be 25. So area is 25 here. What is pi? 25 into 3.14. Okay, so this is 25 into 3.14. This is 25 into 3.1. Obviously 25 25 is the same. 3.14 I have to compare with 3.1. Answer is going to be answer choice B. Right, that's why they have picked this a very peculiar number, 3.1. Okay, let's look at question 11, the ratio of the lesser of two consecutive positive integers to the greater. Okay, so I have two positive consecutive integers. What could those be? They have to be both positive integers. Okay, so it could be 1 comma 1 and 2, 2 and 3, and 3 and 4, 100, 101, like that. Okay, so let's stick to these numbers only. The ratio of lesser to greater, so that means the ratio could be 1 by 3 or 2 by 3, or it could be 3 by 4. Okay, I'm just taking three cases. I need to compare that with 2 by 3. So 2 by 3, 2 by 3 would be same. If I pick 2 and 3, the answer is going to be C. 1 by 2, 2 by 3, obviously answer is going to be B, right? And here 3 by 4, 2 by 3, answer is going to be A. Correct? As the numbers increase, the ratio of consecutive numbers becomes closer and closer to 1, whereas this is only 0.66. Okay, so again I'm getting different cases. Answer is going to be answer choice D. Okay, let's look at question 12. RS is the diameter of the circle. Okay, so RS is the diameter, this is radius. All right, the measure of angle RTS, so RTS, measure of angle RXS. Okay, so X is a point outside of the circle, right? So what about this point that's there on the circle? This is going to be 90 degrees. That much we know, right? So whenever there is a diagonal, the concept is like this, and you take any point on the circle and you connect the diagonal to this circle, this angle is always 90 degrees. So this angle is 90 degrees, that much we know. And for any point outside of the circle, let's say some point here, okay, what would this angle be? Conceptually, obviously this angle is going to be less than 90 degrees. How about this angle? This angle for a point that is inside the circle, this angle is going to be more than 90 degrees, right? So this angle is less than 90, this is 90, that means 90 is bigger, RTS is bigger. Answer is going to be answer choice A. Okay, I'm deliberately drawing extreme figures so that the idea is very clear. Okay, let's look at question 13. X plus 2 is equal to 2, okay, and xy is equal to minus 3. Okay, how do I do that? I can think about a number that is, I can think about two numbers that add up to 2, but their product is minus 3. Let's just start from the product. Okay, so product is minus 3. What are the possibilities? It could be 3 1, or sorry, minus 3 1 or minus 1 3. Let's pick easy numbers. Okay, and which of them add up to 2? I think both of them add up to 2. No, here they add up to minus 2, here they add up to 2. Okay, so the numbers have to be minus 1 and 3. Correct? This is just trial and error. You could have done it using some other trick also. Okay, so but the point is, I don't know which one is X, which one is Y. Okay, I mean, I could have picked 3 and 1 also instead of minus 1 and 3, because see, these are symmetrical expressions, right? So I don't really know which one is X. So, but anyway, it doesn't matter because they are inside a square, right? So anyway, let's take both examples and we'll see. So let's say X is equal to minus 1, Y is equal to 3. This is what I'm thinking. What do I get? x minus y becomes minus 4 square, I get 16, okay, which is the same thing here, so I get C as the answer. The other possibility was x is equal to 3, y is equal to minus 1, okay. X minus y is going to be 4, 4 square is going to be 16. Again, I get 16 and 16, answer is going to be C. So in both cases, answer is still the same, right, because this is square. If this was only x minus y to be compared with 4, that would have been a trickier question, because most people will think, okay, no, sorry, not x minus y with 4, right, x minus y with 4. So in that case, they would just look at only one possibility. There's also the possibility of minus 4. They might ignore that. That would have been a trickier question. Here, there are two possibilities, but answer comes out to be the same, right? So this is going to be answer choice C. Okay, let's look at question 14. In the rectangular coordinate system, segment OP, that is this, O is the origin, OP, is rotated counterclockwise, that is this, anti-clockwise, through an angle of 90 degrees. So something like this they have rotated, okay, to the position OQ. Let's say this is OQ, okay, that is not shown. We are just drawing that. The x coordinate of point Q. So how far is this from x point? So from y axis, right? On in the direction of x axis, how far is it? Okay, horizontally, how far is it from y axis? All right. Now the concept here is, let's look at the numbers, coordinates here, right? 2, 3, and 1. Something should strike, and that is this thing, that if I draw a perpendicular here, okay, what do I get? I get this base, which is the x coordinate, it's root 3, and the height as 1, right? And these numbers are very peculiar. Why? Because again, Pythagorean triangles. So if I look at this, 1 square plus root 3 square, that's 3. 1 plus 3 is 4. Root of that is 2. So this has to be 2, right? And once I know that this is 1 root 3 2 triangle, I can easily say that this is 30 degrees, because only in 30 degrees triangle this will happen. Only in 30 degrees triangle, the side opposite 30 degrees is going to be half of the hypotenuse or the diagonal, correct? So this is 30 degrees. Now I know that if this is 30 degrees and I'm rotating this by 90 degrees, then this will also have to be 30 degrees, correct? And this root 3 remains the same. This root 3 remains the same. Okay, if this is the root 3, again I'm getting the same triangle, am I not? So I'm getting this also as 1. Sorry, this is not root 3, I'm sorry, my bad. Not 3, this is diagonal. This is the diagonal, that is basically I'm shifting this into this segment, right? So the diagonals are, the dimensions are going to remain the same, because this angle is also 30 degrees. So this has to be 1, this has to be root 3. And what am I interested? X coordinate. So that is this. Distance is 1, but in the coordinate system, because it is towards the left of y axis, it's going to be minus 1. Correct? So I get minus 1 here, I get minus 1 here, same quantity, answer choice C. This is a very beautiful question, not very difficult, very beautiful question in terms of the requirement from the student that they should be able to visualize what is happening, right? So I like this question. Okay, let's look at question 15. Triangular garden ABC. Where is ABC? ABC. All right, ABC is here. Is redesigned by increasing the length of AC. Length of AC I'm increasing by 20%. Okay, so let's say original was X and Y. Let me do it here. X and Y. Now what do I have? I have 20%. So it is going to be 1.2x. And decrease in the length of AB, that's the vertical side, by 20%. So it's going to be 0.8y. Okay, 1.2x, 0.8y. What do I have to compare? The area of the original garden. Original garden area is going to be half xy. That much I know. The area of redesigned garden, that's going to be half 1.2x, 0.8y. Okay, so this half is the same, so we can ignore that. Xy is also same, xy is also same, we can ignore that. So I'm basically comparing 1 with 1.2 into 0.8. What is 12 8s are? 12 8s are is 96. So I get 9.96. Okay, I'm just writing I mean, basically it is like this: half 1 times xy, this is half 0.96 times xy, right? Other things are the same, so I'm essentially comparing 1 and 0.96. So, and these are all positive numbers because they are distances, right? So obviously this area is going to be bigger. So answer is going to be answer choice A, right? The trick in this question is that many people might think, if you don't do the math, that okay, one side is increasing by 20%, the other side is decreasing by 20%, so it's going to remain the same. No, that's not. You could have also done it this way. Let's say this was 100, this was 100. 100 times 100 is what I had earlier. I mean, half of that. Okay. But now I have 120 times 96. So do the math. Basically the same thing. Uh, you would realize that this is going to be much, much smaller than this. Okay. So that's question 15. Okay. Let's look at the next set of questions. Question 16. Question 16, 1 by 3 plus 1 by 4, 1 by 3 minus 1 by 4. Okay. Uh, let's do this. Let's keep everything in this format only because they are the same numbers in the denominator in each. Okay. So 1 by 3 plus 1 by 4 is going to be 4 plus 3 by 12 divided by 4 minus 3 by 12. Correct. So this 1 by 12, 1 by 12 as there will get cancelled. So what do I get? I get 7 by 1. 7 by 1 is 7. Answer choice E. Okay. Question 17. The train travels a train travels 60 miles per hour for 3 hours. Okay, so 60, 60, 60, it goes 180 miles. And then 45 miles per hour for 2 hours. Then 45, 45. So till here it is reached 180. Then this is 45, 45 is 90. So here it is reaching 180 plus 90, that is 270. Okay, fine. What is the train's average speed during the 5-hour period? Okay, so it has reached 270 miles in 5 hours. So the average speed is going to be 270 by 5, which is 54. Answer choice B. Okay. Question 18. If 4x is 9 greater than the sum of x and 3y. Okay. Let's be very careful. 4x is 9 greater than the sum of x and 3y. Okay, so that's the expression. Then what is the relationship between x and y? How much is x greater than y? Okay, so let's just solve it. 4x is equal to 9 plus x plus 3y. So let me get x on this side. So I get 3x is equal to 9 plus 3y. Let's divide everything by 3. I get x is equal to 3 plus y. Okay, so x is 3 greater than y. X is how much greater than y? X is 3 greater than y. Answer choice A. Okay, let's look at question 19. Each edge of the cube, okay, so this is a three-dimensional figure, cube, above has a length s, everything is s, all right. Okay, this is also s. What is the perimeter of triangle BCE? What is BCE? So BDE, BDE. Okay, it's a triangle. Uh, let's find out the perimeter. What is this side? This side is the diagonal of, if you look at it from this angle, we have this face of the cube, which is S and S, right? And BD is this diagonal. This is BD, okay, which is going to be again Pythagorean theorem, right? Root square S plus square S, that is 2S square. Root of that is going to be root 2S. This pattern keeps coming in every test that we have done. This is root 2s. Same thing here also, right? This is also going to be root 2s because every dimension is s, and this is also root 2s. So basically 3 times root 2s. That's my answer. Where do I have that? 3 times root 2s is answer choice D. Right? Okay. Question 20. If the perimeter of a triangle is 18, okay, so there is some triangle A plus B plus C is 18. then the length of one side cannot be what? Okay, now this is a tricky question, right? uh, you can do it by trial and error. Can there be uh, one triangle which one side a 1? Yes, it is possible. This is 8.5, this is 8.5. That would give us 17 perimeter plus 1, 18 perimeter. Okay, is it possible to have 3? Yes, it is possible to have 3 also. That means the other two sides have to be, assuming that's an isosceles triangle, other two sides will have to be 15, 7.5, 7.5. Possible, right? Possible 6? Obviously it's possible 6. Everything is 6, 6, 6. Perimeter is 18. Is it possible for us to have 8? Yes, 5, 5, 8. Is it possible for us to have 9? If this is 9, the others will have to be total 9, correct? That means they will have to be 4.5, 4.5. Now you might say, what is the problem in this? Okay, my friend, the problem here is 4.5, 4.5. If you have these two sides, okay, they add up to 9. That means essentially the triangle would look like this. This is the third point. One line is this, the other line is this, okay, and the third line is this. Okay, there would not be a triangle because this point and the third vertex would lie on this line. Think about it. Okay, and that is what introduces us to the other way of solving the problem, which is that uh, sum of two sides have to be greater than the third side, right? So if one side is 9 and all the sides are adding up to 18, right, it is just not possible, because then the sum of other two sides would be 9 only, which is not greater than 9. Correct, it has to be greater than 9. Okay, so that was the trick. If you observe that in the beginning, you could have easily picked 9, but otherwise trial and error also, you could figure out that answer is going to be answer choice. Okay, let's look at the graph question. Okay, interesting graphs. Last time we didn't see any graph in the last section that we did. So here it looks there's a lot of information. Great. All references are in dollars. That are $1985 referred. Okay. All right. So 1975, 1985 total expenditure of medical care. 1975 is this graph. Total expenditure was 240 billion of $1985. Now here what they are saying is that one question students might have is, okay, this is $1985, then what is this 1975? Basically what they are saying that the value of dollar could have also changed over the 10 years, right? So this currency is all these figures are calculated with respect to how strong the dollar is in 1985. Okay, for example, $100 in 1985 may not be the same value as $100 in 1975, right? So that we don't have to worry about that. Everything is given in 1985 is the same currency at one point in time. They may have done some internal adjustment to account for that. Inflation is the correct term, inflation and everything, a dollar value for those 10 years. We don't have to worry about that. Okay, but that could be one potential point of confusion as to what this is. Okay, essentially what they're saying is that the expenditure, source of the expenditure was private insurance, that is this 1975. Out of total $240 billion spent, private insurance spending was $60, so it's $60 billion. Then this federal government was 67, and like that. And same graph here with different numbers, of course, in 1985. Okay, so this is sources and this is distribution. Okay, uh, this was paid by, this was as who's paying for that expense, and this is for what you are paying. So hospital care, you are paying $94, other personal $55, and all that. And you will see that both these numbers are the same. So sources is equal to expenditure. Whatever is the income is whatever is the outflow. Okay. All right. So although this is a little big graph to study, the structure is fairly straightforward. I think I understand that. Let's move on to the questions. Question 21, the category that accounted for $27 billion of distribution in 1975. Let's first identify that without even reading the question. So 1975, which category showed distribution of 27 billion? So 1975, I want to go for distribution. So that is 1975 distribution is this. In this graph, which category showed $27? 27 billion. Okay. So 27 billion, yeah, that is this category. Okay. What is that? This is other national health something. This one. Okay. Correct. Yeah. So for other national whatever for 1975, that category accounted for how many $1 billion of distribution in 1985. Okay, so that category was how much dollar in 1985? Okay, so that category was, categories are the same, $53 billion in 1985. Correct, same thing, right? I'm looking at other national. So 53 is going to be the answer choice E, right? So again, what we are doing here is we are splitting the statement graph. Questions tend to be a little longer than other questions, right? So it's essential that we split the question. Okay, question 22. In 1985, the amount of medical expenditures paid by. Okay, so paid by, that means I'll have to go for this graph 1985 now. Okay, in this graph 1985 paid by graph, what are they asking in that graph? The federal government was how many times the amount paid by state and local government. Okay, so I need federal is how many times state plus local in that graph, right? So let's see that graph. What was federal? Federal is this, which is 125. State and local is this, that is 50. How many times is that? 125 by 50 is, if you divide by 25, you're going to get 2 here, you're going to get 5 here, so 2.5 times, right? Some sort of 2.5 times. 2.5 is here. Correct. Be careful. This is 2.25. This is 2.75. Okay. Let's verify the numbers also. 125 divided by 50 is 2.25. Correct. Right. So answer is going to be D. Okay. Question 23. In 1985, approximately what percent of all expenditures was paid for? So that means I'm looking for 1985 paid for, which is again, yeah, not again. It is this graph here. 1985 paid for graph. In this graph, what? Physician services percent. Physician services was what percent? Physician services is this, which is 83, right? So 83 was what percent of total? 425. 83 was what percent of this total? Okay, so let me round it off, 80 and 400. Let's say if I do that, it's going to be something like 20%. Okay, slightly less than 20%, because actually it's not 400 divided by 425. We are dividing by a bigger number. So in reality, this is going to be less than 20%. Okay. Let's see what number I have, less than 20%. Yeah, approximately they are asking, so 20% is fine. Right? Okay. Let's look at question 24. The percent of total medical expenditures paid by private insurance in 1975. Paid by 1975. Where is paid by 1975? That is this graph, right? Okay. So in this graph, what are they saying? Paid by private insurance percent. Okay. What is that percent? Private insurance. Where is private insurance? Okay. Private insurance is this. That is this number. So that percent is 60 divided by 240. That is 25%. Correct. Okay. Fine. So again, I am splitting the question. 25% was most nearly equal to what percent of medical expenditures paid by which of the following in 1985? So which of the following also paid in 1985? Which of the following was also 25%? That's what they are asking. So I can first of all find out what would 25% of this be. 25% of this is going to be, for 400, it's going to be 100, 25%, right? And for 224, I'm looking at this number now. Okay, for 24 or 25, 4% is going to be 6. So something like 106 is what I need. 106 is already there, which is what? Which is individuals. Okay. Which category accounted for 25% in 1985? So that was individuals. That's answer choice C. Okay. All right. Question 25. What was the approximate percent increase in total medical expenditure from 75 to 80. So I need increase total. Okay, now which graph am I going to refer to? That's a trick question because doesn't matter, is the same number, right? This is the same expenditure, just that this is sources and this is the distribution. So essentially they are saying what was the percentage increase when you went from 240 in 1975 to 425 in 1985. Okay, so what was that number? That's how much is bigger, right? So this is 185 bigger on the base of 240. Okay, 185 on the base of 240, which is you can let's multiply by 2. Let's say this is 250. Let's say 185. Okay, let's multiply by 2. I get 500. I get what? 370 something. Okay, so 370 by 5, so 74 or something, 74%. It went up by 74%, 75% something. Okay, 77%. Answer choice B. Okay, let's move to the next set of questions, which is question 26. In the figure above, N is parallel to P. Okay, so these lines are parallel. So whenever I hear parallel, I just do this calculation. So this is X, this is also going to be X. Okay, if this is Z, this is also going to be Z. So this is X, this is Z, uh, and this is Y, so this is also going to be Y. Right, and in this triangle, all the three angles are coming. So X plus Y plus Z is 180 degree. That much I could figure out. If X is 30 and Y is 80, all right, X is 30, Y is 80, so that's 110 total, correct? Plus Z is 180, so Z has to be 70 degrees. What's the value of Z? 70. Again, see, without even going to the question, I'm just trying to gather as much information as I can. That gives you more clarity rather than just trying to deal with the question directly. Okay, let's look at question 27. Of the following, which is the closest approximation to this thing? All right, so let's look at numbers. We don't really have to worry about the details here because we have to anyway find the approximation. So this number could be approximated to 98 into, let's say, 0.25 divided by 0.51, the whole under root. Okay, don't forget the under root. So let's even take it a little closer. 100 into 0.25, yeah, sorry, I forgot this square, right? Divided by 0.5 square is going to be 0.25. Okay, and then whole under root. Or okay, okay, 0.5, 0.25, 0.25 gets cancelled. 100 root, I get 10. That's going to be answer choice C. Okay, interesting question. Question 28. If X and Y, all right, so X and Y lie on the number line as shown. So X is here, Y is here. All right, which of the following must be true? Now for must be true, we can take any numbers and validate whether that thing is true. Okay, if it is not true, let's say this expression, this equation, if this is not true, then it can be ruled out. If it is true, then we'll take another case and we'll see if it is always true. Okay, so let's say let's easiest thing is to take midpoint. So half, midpoint of half would be 1 by 4. Midpoint of this would be 3 by 4. Okay, 1 by y, what would that be? 1 by y would be 4 by 3. Is that greater than 2? No, that's not greater than 2 because 4 by 3 would be 1 point something. Okay, so this is out. 1 by x less than 2. What is 1 by x? 1 by x would be 4. Is that less than 2? No, that's not less than 2. So this cannot be categorized as must be true. 1 by x less than 1 by y. Let's say 1 by x is what? 4. Is it less than 4 by 3? No, this is 4, this is 1 point something. So this can also be ruled out, doesn't work that way. So answer choice D, 1 x plus y less than 1. Let's say x plus y, 1 by 4 plus 3 by 4 comes out to be 4 by 4, which is equal to 1. So we can't say it is 1 by less than 1. So this is also ruled out. We have ruled out 4 answer choices. The answer has to be answer choice E, but let's just verify. X into Y, so that is 1 by 4 into 3 by 4. That would be Y. What? 3 by 60. Is that less than half? Yes, 3 by 16 is less than half, because less half would be 8 by 16. Okay, so this is true, but that's not sufficient for us to say that it must be true. Okay, because this just could be true only for these two numbers. Ideally speaking, we can take a couple of more numbers and figure out, but that's where we know the answer is anyway E, because we have removed the other answer choices. Okay, but let's look at this conceptually. Okay, and this I'm going to do in a different color. Let's say I have a line segment of certain length, let's say 100. Okay, I multiply by that by a number that is less than 1, let's say 0.9. What do I get? I get this point, I get 90. Okay, let's say I multiply by 0.99, I get this number, 99. Okay, essentially what is happening is that whenever I imagine a positive number, now here we are all distances, so these are positive numbers, and I multiply that by something less than 1, I end up with a point that is towards left. That means towards 0. Correct? Isn't that what is happening here? We have this x, whatever that may be. Okay, and I'm multiplying that with a number that's less than 1, which is y. So would I not end up with a number that is towards 0? Okay, so I will always end up with a number that is to the left of x. That means xy is always going to be less than x, which is less than half. Okay, so xy is also going to be less than half, which is what is given here. Answer choice E. Correct. So there was this sort of conceptual logic you could have also used, but anyway, in this question, because there is this 1 by y, 1 by x and everything, it was anyway much easier for one to figure it out by taking numbers and everything, right? Okay, let's look at question 29. If the product of 5 integers is an odd integer, okay, when do I get a product as odd? When everything is odd, because even if there is one even number, I'm going to get even product. Correct. So all 5 of them are odd. That much I know. Exactly how many of these 5 must be odd? All 5 must be odd. That means answer choice E. Okay. Let's look at the last question. 1/k of a circular pie has been served. Okay, so there is a circular pie. I removed 1/k of that. So k times 1/k I removed. Okay, what is remaining? 1 minus 1k. That much is remaining. If the rest of the pie is divided into n equal serving, so 1 minus 1k I am taking nth serving of that, divided into n servings. Okay, so each serving is this size. Okay, then each of the servings is what fraction? Okay, that's what they're asking. So that has to be 1 by n minus 1 by kn. Let's multiply everything by k. What do I get? I get k minus 1 by kn, something like that. K minus 1 by kn. That's just t. Okay, the other answers are looking very similar, but anyway, in these type of questions you don't go through answer choices. In these type of questions you have to go through answer choices, right? Here we already know it's answer choice D. All right, so that was the eighth test section 2. That's basically the, I think, 15th video, right? 15th video in the series. I found this to be a little easier. Anyway, I keep saying that GRE Big Quant is on an easier side, but even within that set, I think this was fairly straightforward. Didn't find too many tricky questions. There were a couple of questions that required us to do some geometric visualization. The graph was little intricate in terms of the visual presentation of the graph, but once you understand the structure, I think it was fairly straightforward. There was no trick in any of the questions also. So overall, a very comfortable set. That's how I would put it. So so hope you had fun solving this, and keep solving these questions. If there is any special request that you would like me to cover, any specific questions, you can put that thing in the comment, and I'll create a video on that. We can do it that way also. But otherwise, I hope you're following up this whole series one by one. It doesn't have to be in that specific order, but at least I mean, I recommend that you go in that order so that you build some momentum. But if this is the first video, that's also perfectly fine. The point is that you should solve these questions as you're watching the video, as I mentioned in the beginning. All right. So happy GRE, and I'll see you in another video.